Like, subscribe, and hype the video. Also, leave a comment on any topics you want to hear about in the future. Okay, let's dive in. On the morning of June 30th, 1908, something exploded over a remote stretch of Siberian forest near the Podkamenaya Tunguska River with the force of between 10 and 15 megatons of TNT, roughly 1,000 times more powerful than the atomic bomb dropped on Hiroshima. It flattened approximately 830 square miles of forest, knocking down an estimated 80 million trees in a radial pattern pointing outward from a central point in the sky. The shockwave circled the globe twice, detectable on barographs as far away as England. The night skies over Europe and Asia glowed unusually bright for weeks afterward. And when investigators finally reached the remote site years later, there was no crater, no meteorite, no obvious physical remains of whatever had caused the largest impact event in recorded human history. For over a century, the Tunguska event has been one of the most studied, most debated, and most genuinely puzzling events in the history of science. Today, we're walking through everything we actually know about what happened that morning, and in our next episode, we're getting into every theory for what it actually was, including the ones that go far beyond conventional science. Stick around for that one. Let's start with what eyewitnesses actually experienced, because the first-hand accounts of the Tunguska event are some of the most vivid and consistent in the historical record of any unexplained event, and they tell us a great deal about what actually happened that morning. Accounts from the nearest settlements, including the trading post of Vanavara, roughly 40 miles from the estimated epicenter, described seeing a column of bluish light, as bright as the sun, moving across the sky before an enormous explosion and shockwave knocked people off their feet, shattered windows, and sent horses tumbling. One eyewitness, a man named Semenov, sitting on his porch at Vanavara, reported feeling intense heat on his face as if his shirt were on fire before being thrown from his seat by a shockwave that knocked down part of his storehouse. Indigenous Evenki people living closer to the epicenter reported more extreme experiences, being thrown into the air, losing consciousness, finding their reindeer scattered in panic, and witnessing an enormous pillar of fire rising from the forest followed by a thunderclap so loud it seemed to split the sky. Several people reported being temporarily deafened. Seismic stations as far away as Jena in Germany recorded the shockwave, and the atmospheric pressure pulse was detected on instruments in London. Whatever happened over the Tunguska River that morning was not subtle, and it was not local. Like, subscribe, and hype the video, because the puzzle only deepened when scientists finally got there to investigate. Here's a detail that surprises most people when they first learn about the Tunguska event. The first proper scientific expedition to reach the site didn't arrive until 1927, nearly 19 years after the event itself. The reasons for this delay were primarily practical. The Tunguska region in 1908 was extraordinarily remote even by Siberian standards, accessible only by river during the brief summer months, and essentially unreachable during winter, with no roads, no rail connections, and no nearby population centers with resources to mount an expedition. The event happened during a period of enormous political instability in Russia, including the 1905 revolution and then World War I and the Russian Revolution of 1917, during which scientific expedition funding and logistics became essentially impossible to organize. It wasn't until the relative stabilization of the Soviet era that geologist and mineralogist Leonid Kulik was able to secure funding and travel to the site. What Kulik found when he finally arrived both confirmed the scale of the event and deepened the mystery simultaneously. The forest damage was real and extraordinary. Trees flattened outward in a radial butterfly wing pattern consistent with an aerial explosion rather than a ground impact, with trees at the very epicenter standing upright but completely stripped of their branches, like telephone poles, pointing directly at the center of the explosion above them. But there was no impact crater, no meteorite fragments, no obvious physical remains of a solid object that had struck the ground. The specific pattern of tree damage at Tunguska turned out to be one of the most scientifically important pieces of evidence in understanding what actually happened, and it took researchers decades to fully interpret it correctly. The pattern of flattened trees wasn't a simple circle, radiating equally outward in all directions from a single central point on the ground. It was an elongated butterfly shape, wider in some directions than others, and offset in a way consistent with an object approaching from a specific direction at a specific angle, rather than falling straight down. Trees at the very center of the pattern were standing upright, but completely debarked and defoliated, a phenomenon now understood as the result of the downward blast wave at the explosion's epicenter, which pushed straight down from above rather than outward from the side. This pattern is now recognized as the classic signature of an airburst, an explosion that occurs in the atmosphere above the ground rather than at the ground's surface. When an object moving at high speed through the atmosphere generates enough heat and pressure to disintegrate and explode before reaching the ground, the resulting shockwave radiates outward and downward from the explosion point in the air above, producing exactly the kind of radial flattening pattern observed at Tunguska. The absence of an impact crater wasn't mysterious once you understood what the tree fall pattern was actually telling you. The object had never actually hit the ground at all. Like, subscribe, and hype the video. And let's get into what modern science has concluded about the nature of the object itself. The current mainstream scientific consensus on the Tunguska event, built up over more than a century of investigation, including multiple dedicated expeditions, laboratory analyses, computer modeling, and comparison with more recent airburst events, is that it was caused by a small asteroid or comet fragment, somewhere between 50 and 80 meters across, that entered Earth's atmosphere at high speed and exploded in an airburst at an altitude of roughly 5 to 10 kilometers above the surface. At that size and speed, the object would have been subjected to enormous aerodynamic and thermal stresses as it compressed the air in front of it during its high-velocity descent through the atmosphere. For a rocky or icy object of this size, the pressure and heat build up faster than the object can structurally withstand, causing it to catastrophically disintegrate and release its kinetic energy in a fraction of a second, an explosion in the air above the forest, rather than an impact with the ground below it. Computer models of the event produce results consistent with the observed tree fall pattern, the estimated energy yield of 10 to 15 megatons, and the altitude of the explosion inferred from the eyewitness accounts and the geometry of the damage pattern. Microscopic particles recovered from peat layers in the Tunguska region, formed at the time of the event, show chemical compositions consistent with extraterrestrial material, though the fragmented nature of the explosion means large, intact meteorite fragments were never deposited on the surface. Here's why the Tunguska event is more than just a historical curiosity, and why it directly connects to real, present-day concerns about planetary defense that we covered in our DART mission episodes. On February 15, 2013, a similar but smaller object, roughly 20 meters across, significantly smaller than the Tunguska impactor, exploded in an airburst over Chelyabinsk, Russia, with a force of roughly 400 to 500 kilotons. The explosion injured over 1,500 people, almost entirely from shattered glass blown inward by the shockwave, and caused significant structural damage across a wide area. The object was never detected in advance because it approached from the direction of the sun, making it invisible to ground-based telescopes. The Chelyabinsk event was roughly 30 times less energetic than Tunguska, and it still injured over 1,000 people in a populated area. The Tunguska object, had it arrived over a major city rather than an uninhabited stretch of Siberian forest, could have killed hundreds of thousands or even millions of people instantly. Objects large enough to cause Tunguska-scale airbursts are estimated to strike Earth on average roughly once every few hundred to thousand years, rare on a human timescale, but not negligible when you consider what the consequences of a populated area impact would look like. So here's where the conventional science lands on Tunguska, almost certainly an asteroid or comet fragment airburst, consistent with the treefall pattern, the energy estimates, the eyewitness accounts, and the microscopic extraterrestrial material recovered from the site. A genuinely extraordinary event, but one with a physically plausible natural explanation that doesn't require anything exotic. But Tunguska has attracted a remarkable collection of alternative theories in the century plus since it happened, some grounded in real scientific debate, some considerably less so. In our next episode, we're getting into all of them: the comet versus asteroid debate, the antimatter hypothesis, the miniature black hole theory, and yes, the alien spacecraft claims that have circulated since the earliest investigations of the site. Some of what people have proposed about Tunguska is genuinely creative. Some of it is genuinely strange. Stick around for that one. Like, subscribe, and hype the video so you don't miss part 2, and let me know in the comments what you think actually happened over Siberia that morning in 1908. I'll see you in the next one.